Hi boys and girls, this is lecture 1.2 in unit 1. The topic of this lecture, equations and inequalities. Notice I have here the helpful little symbol which reminds us that we will not be using an external calculator for this lecture and for the associated assignment. Before we discuss equations and inequalities, let's define an expression. An expression consists of variables, numbers, operations, and grouping symbols. Notice it doesn't say equal sign. Once an equal sign is inserted in an expression, you have created an equation. So thus far, we may have operators, but no equal sign. Here's an example of an expression, 3x squared plus 5x plus negative 7. And just to define a little bit of the vocabulary we'll be using when discussing equations, if you see a term that has a letter in it, those terms are called variable terms. A term that doesn't have a letter in it is just a number, is a constant term, or perhaps called a constant, and then the numbers that are associated with the variable terms are called coefficients. Going back to this definition, an expression is simplified if it contains no grouping symbols and all like terms are combined. Well, this raises the question, what are like terms? Like terms are terms that have the same variable parts, and it is important for us to be able to discern what terms are like and therefore can be combined, and what terms are unlike and therefore cannot be combined. So in this box there are some examples of like terms and unlike terms. And finally on this slide we have this definition. An expression formed by repeated multiplication of the same factor is a power. And a power has two parts, an exponent and a base. Here's an example of an expression that is a power, 7 cubed. The base is 7 and the exponent is 3. Of course, it is possible for variables to be part of power expressions as well. Now let's get to what an equation is. The definition is that an equation is a mathematical statement which equates two or more expressions. Of course, the word equates is where we get the word equation, and therefore we understand now that the equal sign comes into play. Notice for this sample equation, I have an expression, an equal sign, and another expression. It's okay for an expression to just be a number, as in the case of 13 here. A number is a solution of an equation if substituting the number for the variable results in a true statement. So for this equation, x equals 5 is not a solution, because when I substitute 5 in for the variable, 2 times 5 is 10, plus 5, 15, equals 13. That is not a true statement. So substituting the variable for 5 gave us an untrue statement. Therefore, x equals 5 is not a solution. However, x equals 4 is a solution, because when we substitute the variable for 4, we get 2 times 4, which is 8 plus 5, 13, and that does equal 13. Therefore, x equals 4 is a solution because substituting the variable for 4 results in a true statement. Notice I've created an inspiring wordle here illustrating the properties of equality. Properties of equality are the rules we follow when solving equations. Let's just take a moment to glance at them. We have our old favorite, the commutative property, the associative property, my personal favorite, the distributive property. We also have inverse, identity, additive, multiplicative, transitive. These properties are probably topics in every math class that you've taken. Generally at the beginning of the year, you spend some time going over the definitions of these properties. It is not so important to know the exact definition of each property as it is to understand how to use the properties in solving equations, and also to understand that without these properties, we would not have the process that we need to solve equations. So we take a moment and tip our hats to the properties of equality for providing the rules which allow us to do what we need to do. Now let's solve a couple of equations and see properties of equality in action. We'll start with this one. Notice that the variable is in two different places on either side of the equal sign. When that's the case, it's generally best to consolidate the variable on one side of the equal sign. So I'm going to use the additive property of equality, which says that I can add or add a negative number to both sides of the equation. That's a legal move. And so in doing so, I'm going to be able to consolidate these two variable terms. Of course, I do need to perform this subtraction, negative 5/4 minus 1/3, which requires a common denominator, and that's 12. Therefore, this is going to need to be multiplied by 3/3, and this fraction is going to need to be multiplied by 4/4. So I end up with negative 15/12 minus 4/12, which results in a negative 19/12 d. Over here there is a negative 3 in front of that, by the way, and then on the right side just 1. Now I have successfully isolated my consolidated my variable on one side of the equation. It's time to start moving things away from it. Let's use the additive property again. Adding 3 to both sides gives us negative 19/12 d is equal to 4. And now I'm going to use the multiplicative property. Multiplying both sides by the same number is another legal move. Of course, I am choosing to multiply by negative 12/19 because it's the reciprocal of this coefficient. In doing so, that isolates d, which was my goal all along, and when I multiply 4 times negative 12/19, I end up with negative 48/19. This is your answer. That fraction is reduced and improper, which is the form that you should leave it in. Now let's go on to the second equation. I get to use the distributive property right away. That's always a good time. 1/4 times 7/3 is 7/12 x. 1/4 times negative 5, negative 5/4. Don't forget the minus x. And on the right side of the equation, negative 2x plus 3. Now, I probably wouldn't ordinarily show this step, but just for demonstration purposes, I'm going to switch the position of these two terms, showing you the commutative property. It says that I can switch the position of any two terms that you're adding or multiplying. And since these are negative numbers, I'm adding two negative numbers, it's legal to switch their positions. Now I'm going to use the associative property, which says that I can choose which two I want to add together first. Of course, I've chosen the two that are like terms. 7/12 minus 1 is going to be 7/12 minus 12/12. And that results in a negative 5/12 x minus 5/4 equals negative 2x plus 3. Of course, I do have the variable split in two locations, so I do need to consolidate at this point. Let me add 2x to both sides. This is going to require, once again, getting a common denominator, negative 5/12 plus 2/1. The common denominator is 12, so this is going to be negative 5/12 plus 24/12. And that results in 19/12 x minus 5/4 is equal to 3. Now let's add 5/4 to the other side, again requiring a common denominator. Hopefully I won't run out of room here. 3 plus 5/4, the common denominator is 4, so this will be 12/4 plus 5/4, resulting in 19/12 x equals 17/4. Time to use that multiplicative property again, multiplying both sides by 12/19, which of course is the reciprocal of the coefficient of the variable, giving us x equals, since 4 goes into itself once and into 12 3 times, we end up with 51/19 as our final answer. Reduced and improper. Now let's talk about inequalities. The definition of an inequality is that it is a mathematical statement which compares two or more expressions. Notice the difference between this definition and the prior one is instead of the word equates, we use the word compares. Of course, equates would only be used when you're talking about an equation. But with an inequality, we have several ways of comparing two expressions. And notice the symbols of inequalities are listed here for you. Equals, of course, is with an equation, and then not equal, greater than, less than, greater than or equal, less than or equal, all symbols of inequality that you may use. Of course, here's a helpful little diagram so that you know which number goes with the larger end of the inequality symbol. The solution to an inequality is usually a range of numbers rather than a single number. A compound inequality consists of two simple inequalities joined by the word and or the word or. Compound is simply a word which means more than one, and often a solution to an inequality is expressed using a number line, which you see here. So if you have a sample answer for an inequality, which is something like x greater than 2, well then 3, 4, 5, 6, 7, all of those numbers are answers or solutions for that inequality. So it is convenient to use a number line representation to graphically depict what that solution looks like, and that's what we have here. Notice that when it's less than or equal, greater than or equal, the circle is filled in, indicating that the number is included in the solution. However, if it's greater than or less than with no little line underneath, the circle is open, indicating that the number part of the solution is not included in the range of numbers. Another type of notation that you may have seen is called interval notation, where you use square brackets when it's a closed interval, including the number in the solution, and rounded brackets when it's an open interval where the number is not included. So I'm not sure which notation you have seen before, but either notation is appropriate when graphing the solutions to inequalities. So now let's solve a couple of inequalities. Fortunately, solving inequalities is very similar to solving equations. However, there is one difference, and you must pay careful attention when it occurs. It's known as the glitch. Now, it may not be known all over the world as the glitch, but it is definitely known in my classrooms as the glitch. We watch for it, we're careful, so we don't make a careless error. What is the glitch? When solving inequalities, multiplying or dividing both sides of the equation by a negative number requires that you reverse the direction of the inequality symbol in the problem. So seeing the glitch, recognizing the glitch, helps you to know what you need to do as a consequence of the glitch. So let's go ahead and solve a couple of equations and see if we trigger the glitch. For this first one, notice that D is consolidated in one location, so we need to start moving things away from it. I'll subtract 5 from both sides. This leaves negative 2/3 D, and then greater than or equal to negative 1. Now, adding or subtracting doesn't trigger the glitch, so far, so good. However, our next step will be to multiply both sides by the reciprocal of this coefficient, which, by the way, is a negative number. And yes, boys and girls, that is the glitch. So let's do the multiplication. This becomes D. This becomes a positive 3/2, but now our answer requires that we reverse the direction of the inequality symbol. That's all you need to do. Now let me show you how to make a simple graph to demonstrate this. We don't want a lot of little marks, a lot of little numbers. Do a simple line, a simple circle. Underneath the circle, put the number that is the significant number in the solution, in this case 3/2. Fill in the circle if that's what is required for the solution. In this case it is, since it's less than or equal to, and then simply shade the side or the direction from your circle that is indicated by the solution to the left in this case, since we're talking about numbers less than 3/2, less than or equal. All right, let's move to the second example. Notice it's a compound inequality. There are two inequalities that we need to solve, connected by the word and. Let's do the left one first. Distributing, we get 1/4 times 2, which reduces to 1/2 D. And then 1/4 times negative 6 reduces to negative 3/2, less than 3. So far, no glitch. Let's add 3/2 to both sides. This is going to require that we get a common denominator. So 3/1 plus 3/2, the common denominator is 2. 6/2 plus 3/2 is going to be a 9/2. So 1/2 D less than 9/2. Multiplying both sides by 2/1, which is not negative, by the way, no glitch. And then let me write the answer over here. This becomes D less than 9, our first part of the solution. No glitch involved here, boys and girls. Now let's go to the second inequality. Notice that there's a negative number being multiplied by the variable. Chances are the glitch is going to occur because we're going to multiply by the reciprocal of that coefficient, which is a negative number. In doing so, we get D on the left side. We end up with a negative 6 on the right side, but we have to switch the direction of the inequality in our answer. So now let's graph this. compound inequality, you'll have two circles because there are two significant numbers in your solution. Make sure you put the number that is the lesser value to the left of the other number. Fill in any circles that you should fill in this case only the -6 should be filled in. And notice it's asking us to shade numbers that are greater than -6 and at the same time less than 9, which means this section in between is the range of numbers that this solution is referring to. And now for the last topic of this lecture, absolute value. We'll be looking at equations and inequalities. What is absolute value? Absolute value represents the distance a number is from 0 on the number line. Let's take a look at this number line here and this equation. What number would make this statement true, such that if we took the absolute value of it, its value would be 4? You're probably thinking 4, you're probably thinking -4, and of course both of those answers are correct, because if you strip away the sign of the number, the essence or the true value of the number is that it has a distance of 4 units away from 0. For example, if someone asked you how far it was from, say, Texas to New York, you probably wouldn't say -2,000 miles or +2,000 miles. You would say 2,000 miles, because when you're talking about distance, you're not really interested in the direction that you have to go. More interesting is the fact that it's 2,000 miles. So absolute value gets down to the crux of the matter. What is the real value of the number, regardless of the sign? To solve an absolute value equation, you must first rewrite the absolute value equation as two separate equations and then solve each. Solving absolute value inequalities requires a similar process. Now let me demonstrate why we'll need two equations to solve an absolute value equation or inequality. Look at this little example that I have here. The absolute value of something equals 7. Now, we know that that's a 7 and a -7, that this blue box could be 7 or -7 to make this a true statement. So whatever is under here can be 7 or -7 and make this true. Therefore, whatever is under here will need to be set equal to 7 and set equal to -7 to get both answers that make it true. What is under the box, you say? Well, look at that. It's an expression. Let me move this out of the way. So we now know that this little section in here, whatever it is, can be equal to 7 to make this true, and it can be equal to -7. Well then, that requires two separate equations. 2x minus 5 equals 7, and 2x minus 5 equals -7. Solving them both will give us the two answers to this absolute value equation. In this case, 2x equals 12. 6 is one of our answers. And in the second equation, we have 2x equals -2, x equals -1 is the other answer. Let's see if these are true. 2 times 6 is 12, minus 5, 7. The absolute value of 7, of course, is 7. Now let's try -1. 2 times -1, -2, minus 5, -7. The absolute value of which is also 7. Great. We used two equations and we got both solutions to the absolute value equation. So let's solve a couple more of these. Look at letter A. Now, a couple of things are different than the one we saw before. First of all, there's a number hanging around outside the absolute value quantity. We do not distribute it in. Never, never, never. The absolute value bars are like castle walls. Nothing goes inside. And so we have to think of another way to remove the 3 from the left side of the equation. And there is a way. Let's just divide both sides by 3. So we don't make us two equations until the absolute value quantity is alone on one side of the equation. Therefore, do whatever is necessary to move anything straggling around out here to the other side of the equation. And then once this is isolated, you can make your two equations. Something else that's different is the right side has a variable in it, and that's okay. Now, it does introduce an element of uncertainty, and when there is a variable over here, we do need to realize that we may get solutions that seem valid but actually don't work in the equation. So we need to make a note to ourselves to check our answers when there is a variable. on the right side of the equation. So mental note to yourself to do this at the end. And so now that the absolute value quantity is isolated, we make our two equations. The expression inside the absolute value bars never changes. You don't change the sign in here to positive or negative. It stays intact for both equations. The first one will let it be equal to negative 7x, and the second equation will let it be equal to a positive 7x. Now, moving these variables together to the right side requires that I subtract x from the left. This gives me negative 8x, and dividing both sides by negative 8 gives me one potential answer, negative 3. I say potential because, once again, remember, we have this air of uncertainty in our answers now because of the variable. Let's subtract x from both sides in the second equation. 24 is equal to 6x, giving us another potential answer, x equals 4. Now, let's just quickly try these and see if they work. Negative 3 plus 24 is 21, the absolute value of which is 21, times 3 is 63. On the right side, negative 21 times negative 3 is also 63, so x equals negative 3 is a valid answer. Let's try 4. 4 plus 24 is 28, times 3 is 84. On the right side, negative 21 times 4 is negative 84. 84 does not equal negative 84. So 4 was what we call an extraneous solution, seemingly valid, produced by a seemingly valid process or a correct process, but still, because of this variable in the initial equation, it turns out that it was not an actual solution. All right, now let's solve the absolute value inequality. Right away, you probably notice that there's a negative 5 out here hanging around outside the castle walls. Do not try to combine these. There will be no such shenanigans here. These are impenetrable castle walls, so the only thing that you're able to do to deal with that negative 5 is add it to the other side. Now that the absolute value quantity is isolated on the left side of the inequality, you can set up two inequalities to solve. So we do this. We're going to say 1/7 y plus 2 is greater than 8. The first equation looks very much like the original inequality. And then 1/7 y plus 2, we will change the direction of the inequality and the sign of the number for the second inequality. So that's two small changes that need to be made to set up the two inequalities. Now notice that you now have a compound inequality, two of them. Because of this, we need the word and or to connect them. So going back to the original absolute value inequality, if the original inequality has greater than or equal to, then that requires the word or to join the compound inequality. If the original inequality has less than or equal to, that requires the word and to join the inequality. So for this inequality, these two inequalities, we will need the word or since the original symbol was greater than. Now let's solve them. We subtract 2 from both sides. 1/7 y greater than 6. Multiplying both sides of this inequality by the reciprocal of 1/7, which is a positive number, yields this answer, y greater than 42, the first part of our solution. Now let's solve the second inequality. Subtract 2 from both sides. We end up with 1/7 y less than negative 10. Once again, multiplying both sides by 7/1. You end up with y less than negative 70. Remember, this is an or inequality, so as we graph the solutions, we'll have two circles. Negative 70 is smaller than 42, and they're asking us for those numbers that are less than negative 70 or larger than 42. Therefore, this is the graph that depicts the solution to these inequalities. That's the end of today's lecture, boys and girls. God bless you.